Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. MCPBA is a peracid that performs epoxidation of alkenes via a concerted S-Y addition mechanism, both oxygen atoms delivered to the same face of the double bond. The substrate shown is allyl alcohol, 2-propan, 1-ol CH2 is equal to CH2O. Step 1. Identify the substrate. The structure drawn is allyl alcohol, CH2 is equal to CH2O, a simple terminal alkene with a hydroxymethyl group. Step 2. Epoxidation with MCPBA. MCPBA reacts with the C is equal to C double bond to give glycidol. 2. 3. Epoxypropan, 1-ol, also known as the epoxide of allyl alcohol. The product is an epoxide, an oxirane ring bearing a CH2O substituent. Step 3. Analyze stereochemistry of the product. Glycidol has one chiral center, C2 of the epoxide ring. Since the starting material, allyl alcohol, is achiral and the MCPBA epoxidation is not enantioselective, no chiral catalyst, the reaction produces equal amounts of R and S glycidol. This is a racemic mixture. Step 4. Evaluate options. A. Meso, incorrect. Meso requires at least two stereocenters with an internal plane of symmetry. Glycidol has only one stereocenter. B. Racemic, correct. Equal amounts of R and S enantiomers are formed. C. Diastereomers, incorrect. Diastereomers would require two or more stereocenters giving non-mirror image stereoisomers. D. Optically inactive due to absence of chiral center, incorrect. The epoxide product does have a chiral center. Therefore, the correct answer is B. Therefore, the correct answer is option B.